Okay, this one example. The primary winding of a delta star, so that's our transformer connection is delta star. Primary is delta, secondary is star. 50 volt ampere, that's the rated apparent power. Remember, volt ampere is the complex power, is the magnitude of the apparent or complex power in volt ampere. S, capital S. Transformer is supplied with a 100 volt 60 hertz three-phase source. So the transformer is supplied. The transformer is typically supplied in the primary side. So this means this is the E line to line in the primary side. That's the frequency of the source. American standard. Three-phase source. The transformer has 500 turns on the primary winding side. So this means the 500 is in the primary in B, and 100 turns on the secondary winding. So this is going to be in S, number of turns in the secondary side. Questions. Calculate first the transformer turns ratio. Whenever we ask typically about transformer turns ratio, it means find how much is in the primary over in secondary. That's the turns ratio, and typically they call it A, right, in the textbook. But don't worry about this. Now we can just keep it NB over NS, right? So what is NB over NS? Basically, this is 500 over 100. That's 5. This is 5. What about opposite of that? NB over NS. There's another way of saying opposite of that turns ratio is NS over NB. Is basically opposite 100 over 500 or 1 over 5, which is 0.2. So depending on what you need to use in your equations, whether NB over NS or NS over NB, you can use any one of them, as we will see later. So one is done. 2. The secondary side line voltage. So what we're looking for here, the line to line voltage where? In the secondary side. So let's go back to the previous recording videos, previous parts, and we recall our equations for delta star. So what is our equation for delta star? E line to line secondary is NS over NB, right? E line to line secondary is NS over NB times root of 3 E line to line primary. Right? This is our equations. So if we put the numbers, this is NS over NB is 0.2 and root of 3 is there. Line to line primary. What is line to line primary? It's given in the question. 100 volt. 100 volt. If we multiply this is almost 1.73. So this is going to be 173.2. It means 173 over 5. We're talking about 173 over 5, we're talking about 34.5, something like this, 4.7 maybe, 34.6 average volt. Right, so let's look by calculator and check. It should be around this. 34.6 voltage. What is this? Line to line in the secondary side. Remember, secondary side is what? Star connection. In the star connection, we know that there is a difference between line to line and line to neutral, or line to line and phase. Always line to line in a star connection is greater than the phase by root of 3. Okay? So number 3 is saying find the secondary side phase voltage. There we found line voltage in the secondary side. What about the phase voltage? Easy. We go back to the lectures of three-phase circuits. We know the relation between them, that E phase is E line to line over root of 3. We know this in the star connection. Remember, we are still here in the secondary side, which is Y connection or star connection. So in star connection, it's line to line over root of 3 gives you the phase. So this will be, this means E phase in the secondary side is line to line, which we just calculated, 34.6 over root of 3. So again, we're dividing 34.6 over 1.73. This is 20 volt, 20 volt. So that's the voltage in the secondary side. Note that this voltage should be always and always less than the line voltage. We know line voltage is always greater than phase voltage. In Y connection. In delta they are the same. Right. Number 4. The secondary side line current. Secondary side is the star connection. And we need the line current there. Now, what is given in the question here that can help us to find the current? We know the voltage. We need to calculate currents, right? But there is no any current given here. So, in order to calculate current, you need to look for power, basically. Any given value for powers. We have this. The rated is 50 volt ampere. That's the apparent power of the transformer. And we're saying that we're assuming the transformer is ideal. So this is the apparent power in the primary, and it will be transferred to the secondary, delivered to the load. So, remember again from three-phase circuit lecture, S of a three-phase system is root of a 3, I line, E line. So from here, what we're looking for here is secondary line current. So what will be currents? I line in the secondary will be S of a three-phase over what? Over root of a 3, E line to line, secondary, because we are on the secondary side, right? Yeah. So what is this? 50. This is given in the question. 50 over root of 3 over root of 3. Let me just write it. This is 50 equal to 50 over root of 3 line to line secondary. We calculated this somewhere. That's line to line secondary. 34.6 volt. And this is 50 over root of 3 over 34.6. This should be less than 1, maybe 0.9, 0.8, 0.8, and there is like 0.33 times. Yeah, so this is almost 0.83. 83 watt ampere. 83, it's a third there, so it's 833, let's see. Ampere. So that's the secondary line current. That's the star, right? The secondary side is Y connection. What about if I ask you about the secondary side phase current? This is the secondary side line current. What about the secondary side phase current? Let's think about it. What is our connection in secondary side? It's a star, it's Y. What's the relation between the line current and the phase current in star connection, in Y connection? They are the same. They are the same. Go back to our lectures about three-phase circuits. That's why here it's not requested in the question. If I ask you in this, you would have to say basically the secondary side phase current is equal to secondary side line current because it is a star. It is Y connection here. What about the primary side line current? We can either apply the same formula here, but because S is the same in primary and secondary, assuming ideal transformer, it will be root 3 again. We're looking for I line, but I line this time will be for primary. Then you have to multiply, you have to divide here by E line to line primary. And it will give you the value of the current. Alternatively, we can use the Turner's ratio from our previous parts of explanation. When we go back to our equations, what's the relation between the primary or the line, the primary line current and the secondary line current? Go back, recall the equation from delta star transformer. The line in the primary is equal to NS over NB times root of 3 line in the secondary, right? Remember when you check the equations there, remember we started by I line secondary in the equation. That's why it was over root of 3. Here, I changed it. I just flipped the equations. Easy, come on, right? Yeah. So, what will be this? NS over NB, how much? NS over NB, we just calculated, that's 0.2 times root of 3. And I line secondary, where is I line secondary? I line secondary is this 0.833. So this is almost point 0.29 maybe. 288. Let's say 289 ampere. That's the primary side line current. Okay. Number 6, the primary side phase current. Okay, let me check. What is our connection in the primary side? Delta. Right. What is the relation between the line current and the phase current in delta connection? In Y connection, they are the same. In delta, they are not. Line current is always greater than phase current in delta connection by factor of root of 3. So we're looking here for what? For the phase current. So we know that I phase in the primary is equal to I line in the primary divided by root of 3. So this is 0.289 over root of 3. This is gonna be 0.1, maybe 66, let's say 67 ampere. And here is the solution. Here's the solution of examples, right? Okay. So we'll put some assignments on these connections. Hopefully this week or next week. Okay. So now, as a summary, we talk about the 3 conventional type of connecting 3 single phase transformers to 3-phase connection. Y, primary is Y, secondary is Y. Delta, primary is delta, secondary is delta. Delta Y, primary is delta, secondary is Y. Y delta, primary is Y and secondary is delta. And you need to know the equations for all of these 4 connections, voltages and current. Okay? Right, I'll see you in the next week, the next lecture about induction motors. Thank you, and good luck with your exams.